All right. We're starting Unit 3. There are three parts to Unit 3. There's system of linear equations, which is what we're doing right now. Then we'll do systems of inequalities. Then we're going to do some geometry concepts. All three of the parts to this particular unit are very small, so they kind of clump them into one unit. All right. So let's go ahead and get started with systems of linear equations. We're going to do the vocabulary part first for the first part of this unit. And we have systems of equations. But I'm going to add the smaller word. I'm going to squeeze a word in there. And I'm going to say system of linear equations because that's what we're going to do first. Remember that a linear equation are equations that graph straight lines. You have to remember that. System of linear equations are equations that graph straight lines. A system though, system meaning more than one, is going to be a set of equations with, got my eye, the same variables. Okay, so we're going to break this down real quickly. Where you see a set of equations, technically, and I'm going to write this here so it can give it more meaning if you're confused by the verbiage, is more than one equation. Okay, so a system, like a bus system, is more than one bus. You can't have a bus system with just one bus. You can't have a school system with, let's keep it going. Please make sure that you stay mute. Okay, please make sure that you stay mute. All right. So a set of equations means that it's more than one equation. In this unit, we're going to deal with solving two equations. When you get to other courses, well, I should say in this particular course, Math 1, we're only going to do two equations at a time. We're going to solve two equations at a time. When you get to future courses, you're going to do 3 and 4 equations at a time, right? The other part of this is not only is it just more than one equation, but both of those equations have the same meaning to both x and y. So that means if x in the one equation represents the number of hours, then x in the other equation also represents the number of hours. If y in one equation represents the total profit, then y in the other equation also represents the total profit. The x and the y in both equations mean the same thing, okay, in order for it to be a system. These are some characteristics of a system, okay? We got two bullet points here. We'll talk about two major characteristics. The solution to a system is going to be all of the points that the equation share. The solution to a system, I'm talking about a system of equations, that is, the solution to a system is going to be all the points that the equations share, or ordered pairs. And in parentheses, I'm going to put lines. Okay. All the points the equations or lines share. So all the points that they have in common is going to be the solution. Okay. Now I'm going to pause for the calls to give you a chance to write. Okay. The next characteristic that we need to know about systems of linear equations is that there are three possible solutions. There are three possible solutions. There are three possible solutions. And they are as follows. Okay? You have a no solution. It's weird how I started with that one first, huh? A no solution is when the lines, they don't share any points. That means they're parallel. They don't share any points. They don't cross each other. They don't touch each other. That's a no solution because remember, a solution are going to be all of the points that they share. So if they don't share any points, there is no solution. Okay? The second possible solution is going to be one solution. One solution means that the lines cross each other at one point. So whatever point this is, whatever x and y value is, this is going to be the solution because they share one point. So this is the solution. That one point that they share is the solution. It's only one of them because remember, if it's a straight line is not going to loop back around and touch that line again. Then it's not straight anymore. So either it's not going to touch or it's going to touch. And then that brings us to the last possible solution, which is going to be infinitely many. An infinitely many solution is going to be where the lines are right on top of each other. That means every point that's on one line is a point that's on the other line. They share all of the same points. And since a line never, ever, 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 ever ends, that means it has an infinite number of points. So this is infinitely many solution. So a system of linear equations or straight lines, either the straight lines are not going to touch each other, which means it's a no solution. The straight lines are going to cross at one point, which makes that one point the actual solution, or the straight lines are going to be right on top of each other. If they're right on top of each other, that means that they share all of the same points. That's infinitely many solutions. And I'm going to pause so you can write. Consistent is when the lines touch. Inconsistent is when the lines do not touch. And these again are they're describing a system. All right, I'm gonna keep moving. I forgot to actually pause it, but that's okay. Keep going. All right, two other vocabulary words that you need is independent and dependent. My independent on my page got chopped off, so I'm gonna write independent up here. Independent and dependent. Independent means that the system has only one point that they share. So there is one solution. I'm gonna go ahead and draw a line. So if the system is independent, there is exactly one solution. Okay? And that looks like this. Of course, they touch each other, but it's where they cross at one point. This one point is the solution, okay? Whatever that ordered pair is going to be the solution. That's the point that they share. Okay? Dependent is where they share all the same points. This is infinitely many solution. And that's where you have two lines that happen to be right on top of each other. They graph the exact same line. That means every single point that's on one line is a point that's on the other line. And these are words that we use to describe a system. These are words that we use to describe a system of linear equations. Okay. And I will pause. Okay. Now we're going to take these vocabulary words and put them into like a graphic organizer. Okay. I'll take those vocabulary words and put them into this graphic organizer. All right. So a system of linear equations or system of equations is either going to be consistent or inconsistent. So we're going to put consistent here. Oops. So a system of linear equations is either going to be consistent, that means lines touch, or they're going to be inconsistent, lines do not touch. Okay? So either the equations or the lines, when you graph them, either they're going to touch or they're not going to touch. If they touch, you say that they are consistent. If they don't touch, you say they're inconsistent. Any questions? Are y'all okay? All right. If it's consistent, that means if the lines touch, they're either going to be independent or dependent. Okay? So if they're consistent, if the lines touch, they're going to either be independent. Independent means they only touch in one place, so it's one solution. They cross in one place, one solution. Or they're going to be dependent, which means they're right on top of each other. They depend on each other. They're right on top of each other. That's infinitely many solutions. They share all of the same points. And these are the vocabulary words we use to describe a system. And I'll pause to make sure you have this written. All right, let's keep going. So now we have examples of the three different kinds of solutions. So there are three different examples that we're gonna describe each of these systems. So in this first example, we're gonna put example 1. And let's suppose that you graph the equations and you get a line that's going in this direction and you get another line that goes in this direction, okay? It has one solution. It has whatever this x and y is. It's only one solution because they only share, these lines or equations only share one point. They cross at one point. They share only one point. Okay? Because they touch, are they consistent or are they inconsistent? Anybody know? Is it consistent or inconsistent? Very good. It is consistent. Excellent. Okay? And these are descriptive words. Okay? Since it is consistent, is it going to be independent or dependent? It's independent because it only shares one point. There's one solution. So these are the two vocabulary words that we use to describe this system. This is what we do to describe the system. This actual point is going to be the solution. This actual point is going to be the solution. Okay. Example number 2. Example number 2. Okay. You have 2, and I'm putting arrows at the end of the lines because they're not line segments. They're lines that continue on forever. So putting arrows on them. You have 2 lines that never touch each other. They're parallel. That means they have the same rise over run. They have the same slope. Okay, they're parallel. Because they don't touch, are they consistent or inconsistent? Very good. They are inconsistent. So the vocabulary word that we use to describe this system is inconsistent. Okay? Since it is inconsistent, it's nothing else. There's no other vocabulary word to describe this but inconsistent. If it asks for the solution to this is a no solution because it does not share any points. So if it asks for the solution, there is no solution. That's the answer to this. And it's no solution.
Teachers and students, please pardon this interruption. If there are any students in the building who need to double check on their bus transportation and bus number for this afternoon, any 6th graders or any students on campus
I'm going to pause,
need to
okay,
double
y'all?
check.
All right. So inconsistent, again, that means the lines don't touch. It's a no solution again because they do not share any points. They don't share any points, so there's no solution. Okay. The last possible type of solutions for a system of linear equation, number 3. Here, we're going to draw 2 lines that are right on top of each other. Okay? We're going to draw 2 lines that are right on top of each other. Is this consistent or inconsistent if they're right on top of each other? Anybody? Is it consistent? It's consistent because they touch. If they touch, it's consistent, okay? Now, since it's consistent systems either have independent or dependent. Which one is this one? Is this independent or dependent? It's dependent. Very good. Okay. They're right on top of each other. That's infinitely many solutions. So the 2 descriptive words that you use for this system is consistent and dependent. Okay. If it says, what is the solution to this system? It's infinitely many solutions because they share all of the same points. There's an infinite number of points because by definition, a line continues without end. So since this line continues without end, both of them do, they have an infinite number of points that they share. So this is infinitely many solutions. This would be the answer for this one. Whatever this is here, this 1 point that they share, this ordered pair would be the answer to this one. And no solution because the lines don't touch. This will be the answer to this system. Okay, I'm going to pause so you can write. All right, so here we go. These are going to be some examples that we do. For these examples, we're going to use what you call the graphing method. So you can use a text box to type this in or write this in with the writing tool. But we're going to be graphing. We're going to use the graphing method to solve the system. Okay. And I'm going to put a little asterisk because I needed to tell you what that means. That means you're going to graph these lines, these equations, to find out what points they share. Okay? So you're going to graph the equations to find the solution. And what that means is what points do they share. What points do they share? Either they're going to share 1 point, no points, or all of the points, infinitely many. Okay? This is how that works. Let me pause real quickly. Okay. So when you're graphing these two equations, they must be written in what you call slope-intercept form. Remember that slope-intercept form is y equals mx plus b. When equations look like this, you can graph them. If they don't look like this in slope-intercept form, you can't graph them. Okay? So now let's do that. Let's write these both equations in this form. So I'm going to rewrite each of them. Please watch what I'm doing because you'll do this other two the very same way, okay? Right. So to write each of these equations in y equals mx plus b form, you got to get y by itself, okay? So in order to get y by itself, you got to get rid of this positive 2x. The opposite of a positive 2x is to subtract 2x on both sides of the equal sign, okay? When you subtract 2x on both sides, this is 0 here, and we're left with a negative y is equal to, and here, look at these. You can't combine these terms because they're not alike. So bring them both down. Doesn't matter which one you write first. I'm going to write the negative 2x first. Then minus, because there's a negative in front of it, so I'm going to write minus or negative 3. To get y by itself, so it's in y equals mx plus b, you got to get rid of this negative. So to get rid of this negative that's attached by multiplication, you're going to divide everything by negative 1. That's going to give you a negative divided by negative is a positive y. Negative divided by negative is going to give me positive 2x. Negative divided by negative is going to give me that positive 3 here. Okay, and I'm going to graph this equation, okay? Let's write this equation in slope-intercept form. If you need me to hold off for a second, please raise your hand. Okay, I'm going to keep going. Here, to get y by itself, I'm going to get rid of, just like I did over here, this 8x. It's a positive 8x, so I'm going to subtract 8x on both sides. Okay? When I subtract 8x on this side, this is gone. This is 0. And I'm left with, don't forget the sign that's in front of this, a negative 4y or minus 4y, however you want to say it. You can't combine these terms here because they're not alike. So bring them both down. Doesn't matter which one you bring down first, okay? I'm going to bring down the negative 8x or minus 8x and the minus or negative 12. Now to get y by itself, I have to get rid of this negative 4, which is attached by multiplication. The opposite of multiplication is division. So we're going to divide every single term, just like we did over here. We're going to divide every single thing with negative 4. Okay? So that we can get y by itself. Negative 4 divided by negative 4 gives me 1. So this is 1y, positive 1y. Negative again divided by negative is a positive. So this gives me a positive 2x. A negative divided by a negative gives me a positive. So this is going to be a positive 3. And what I notice about both of these equations is that they are going to graph the exact same line. So now let's graph it. Label your M. Label your B. And all of this part was a review anyway. So M is going to be the number in front of X, which is 2. Remember that you have to write it as a fraction, so just put a 1 under it. And remember, that's because you have to have a rise over a run when you graph. B is going to be the number that has no variable attached to it, so that's a positive 3. So now we're going to find positive 3 on the y-axis. This is the y-axis here. Okay. I'm going to start here at the origin, and I'm going to find positive 3 by going up 1, 2, 3. This is where I start. This is my y-intercept. Then I'm going to use my slope. Positive 2 is rise, so I go up 2, 1, 2. And positive 1 is run, so that because I go to the right 1. So I continue this pattern. Up 2, 1, 2, to the right 1. Up, 1, 2, right 1. If I want points in the opposite direction, instead of going up 2, go down 1, 2. Hold on, guys. Let me get that out the way. Okay. All right. Go down 1, 2, and to the left 1. Lost my train of thought for a second. Down 1, 2, left 1. 1, 2, left 1. 1, 2, left 1. And just continue that pattern. And now you have a straight line. Remember that both of them are the exact same. So do a double line, do double arrows. Okay. So the solution here, they share all of the same points. So your solution is going to be infinitely many solutions. This is your answer. How would you describe this? What descriptive words would I use? Is this consistent or inconsistent? Anybody? Very good. It's consistent because they touch. Excellent job. Okay. Since it is consistent, is it independent or dependent? Anybody? It's very much so dependent. Excellent job. So this is the description. This is the answer. This is the description. This is the answer. Any questions before I stop the video? Okay. The other two, I need you to do example 2 and example 3 on your own. And we'll go over those tomorrow. Okay? But you need to do examples 2 and 3 on your own. Anybody lost? Are we okay? I'm going to stop the video at this time.